Hello, everybody. Hello, welcome, and thank you for attending this Yole Development live market briefing dedicated to the microcontroller market. My name is Faisal Kamasi. I'm Sales Coordination and Customer Service for Yole Development. Based on how MCU monitor, the aim of this live market briefing is to provide you in 30 minutes an update-to-date analysis of this market with a focus on COVID-19 impacts. How principal analyst in Computing and Software Division at Yole Development, Tom Ackerberg, will provide a snapshot of the overall market for MCUs and a few of the major market trends extracted from the Yole's highlight detailed Microcontroller Market Monitors 2021 Q2 edition. Before we get started, I remind you that you are encouraged to submit questions to our analysts during all the live events using the Ask a Question windows at the bottom of the screen. Question will be answered right after the presentation. In case we don't have time to answer all of them, we will follow up with you by email. To conclude, this live event is recorded. You will receive tomorrow an email with the link to access the recorded session. So let's start the live market briefing and welcome Tom. Tom, the floor is yours.
Thank you, Faisal. Welcome to the live market briefing. Why can't I buy a car? The automotive market is broken. Consumers have noticed. In reality, consumers more often don't care why something is broken. They just want it fixed or to know when it will be fixed. But when consumers are upset about something, the media notices and it becomes news. In the news, there is a semiconductor shortage, but this is misleading. The term semiconductor describes the materials that integrated circuits are commonly made from. But to say there is a semiconductor shortage is not really describing the problem. Because of its importance in the market, I'm going to take most of this time to clarify this supply chain disruption before talking a little bit about the other MCU trends. In almost every electronic device market, there's a pattern of demand that is frequently adjusted quarterly, if not monthly. Understanding and predicting this pattern in markets for complex electronics like automobiles, computers, manufacturing, aerospace and defense, and many others, so that the cost of over or undersupply is minimized. The strategic model for accurately predicting the complex supply of parts is often referred to as just-in-time supply chain management. It has become a significant tool in reducing costs in all electronic markets, but especially in products where many components are needed for the final system. This chart you're seeing represents the various microcontroller markets and how much automotive impacts the overall microcontroller market. It also highlights the beginning of the supply chain disruption. The reasons for the disruption are complex, but here are the many main triggers and contributors. First, the just-in-time model designed to ship just the right amount of components at just the right time was thrown a curveball by geopolitical trade wars starting before the pandemic. In some markets, OEMs were trying to predict new supply chains and adjust to the possibility of changing tariffs. The models were at risk as orders were disrupted and some stockpiling began to occur. Next, the COVID-19 pandemic pressed the model to the breaking point when workforces dropped due to illnesses and world and national health services recommended a shift to stay-at-home offices when possible. To throw more fuel on the fire, natural disasters, including fires and storms, disrupted manufacturing. In the first half of 2019, these events caused consumers to turn their focus away from how to get to work to making working at home a reality. Automotive OEMs and tier 1 suppliers expected the market to continue to decline and reacted by delaying model releases, reducing workforce, and most relevant to us in our discussion, canceling component orders. It's not fair to blame this disruption completely on OEMs. The common sense was people were not going to have the money to buy cars. This graph shows the initial sharp drop, but consumer demand for automobiles quickly recovered as people compared the risk of public transportation to taking cars to work. So despite the ongoing risks of the pandemic, and in some ways because of it, demand for automobiles is actually expected to grow. The chart you're looking at shows that growth is substantial. And with that, so will the markets for MCUs and other components. The MCU market alone will grow to over $24 billion US in 2026, with automotive alone rising to 9 billion of that. But that still does not stop low inventory from making news and driving up pricing. Not only are car sales growing, strong trends for microcontrollers continue as electrification, advanced driver assist systems, and connected car user experience drive demand for more and more powerful processors, including trends in MCU design. 5G communications and Industry 4.0 are also growth drivers, as can be seen in this chart. In discussions with MCU suppliers, current disruptions have little to do with semiconductor material shortages or even the early catastrophic events that started to trigger this effect. When automotive OEMs canceled orders early, the foundry services found other markets eager to capture the newly available foundry capacity. Automotive OEMs attempting to reestablish their orders found they had to wait in line for capacity as foundries attempted to fulfill orders for components for home offices, computers, mobile devices, and other high demand areas. Apple's switch from Intel to M1, their own processor, is just an example of newly allocated capacity. Changing manufacturing from producing computer processors to drivetrain controllers is not as easy as flipping a switch. These are very different masks, packaging, test, and validation. While independent design manufacturers and foundries struggle to provide a fair distribution of capacity, what is more clear is the just-in-time supply chain is bent to the point of being broken. Demand and supply are both high, but as adjustments to fulfill some order deficiencies are made, others may be delayed as much as 5 weeks or more. Shipping is congested. Semiconductor suppliers claim that it is very difficult from 1 month to the next to understand which components are out of balance due to the unpredictability of this disruption. So to be clear, it's not a shortage, but a supply chain imbalance that we are talking about. Another dynamic of the supply chain disruption is the increase in pricing. In this graph, the supply chain disruption, including trade wars, COVID, catastrophes, and current increasing demand on IDM and foundry capacity, is driving prices up. Microcontrollers' average pricing is expected to rise. This is unusual for the microcontroller market. Most microcontrollers are built on mature technologies and frequently drop as mature processes get cheaper. But new products with more features replace more mature products to bolster that price. Still, the price tends to stay the same or drop. However, the supply chain imbalance and high demand for premium foundry services are causing many foundries to announce price increases of 10 to 15% or more. These extreme increases will have a trickle-down effect on more mature technologies. Automotive, which is more of a leading-edge demand for MCUs, is expected to see stronger alignment with these price increases, and the average will jump from just under $2.20 to close to $3 in 2022. By 2023, the MCU market will have more successfully balanced a new just-in-time model with more hybrid models of stocking critical components and second sourcing. Current fab investments are expected to bring a large amount of capacity online by the end of this forecast, bringing the microcontroller pricing trend back closer to earlier models, but settling higher than pre-pandemic pricing. There are an estimated 60 or more companies with some microcontroller designs. We track around 40 estimated at $50 million or more in the annual microcontroller revenues, but over 80% of the market is supplied by these top 8 microcontroller suppliers. Renesas, these 5 microcontroller suppliers, Renesas, NXP, Infineon, ST Microelectronics, and Microchip. If one of or more catastrophic events impacts the supply chain through one of these independent design manufacturers, it has an impact on the supply chain, as we've seen. The other effect of this is to show that in many ways, the supply chain disruption is as much a demand impact on the MCU market as it is a supply issue. As the leading edge microcontroller designs are impacted by the redistribution of foundry allocation at TSMC, SMIC, UMC, Global Foundries, and other foundries, these independent design manufacturers have adjusted by increasing capacity at their own fabs. However, the strongest impact on automotive seems to be at the premium models, where vehicles may be waiting on the latest high-performance SoC or a display driver or some other component. So even though these cars may be able to get all the classic microcontrollers they need, they may still be waiting at the factory for some other component that is delayed. That delay could be due to a competition for foundry capacity as much as simply shipping delays or COVID impacting port processing or other supply chain delays. This is another indicator that semiconductor shortage is not a very precise description of the current market disruption. On the other hand, almost every independent design manufacturer has shared some adjustment to their strategic roadmap that relates to relying more on foundry services for future generations. As microcontrollers push closer toward cutting-edge manufacturing techniques, the business model to rely more heavily on cutting-edge foundries instead of classic process nodes continues to drive an increased share of manufacturing toward foundries. Markets like automotive are driving more demand for higher performance and more compatibility with cutting-edge software and tools. This, in turn, is driving the trend toward advanced 32-bit microcontrollers, as shown in this chart, with significant integrated features, including advanced memory, security, vision and audio AI processing, and other features that will compete more with system-on-chip solutions for both application sockets and the advanced fab capacity. As can be seen in this graph, microcontrollers are not in the mainstream news with their less than cutting-edge geometries. For various integration, design, and cost limitations, they will never achieve cutting-edge process nodes like your computer microprocessors or your mobile handset SoCs. But the gap between microcontrollers and leading-edge manufacturing for MPUs, GPUs, and advanced SoCs is getting smaller every year. All of these significant growth is pushing towards process nodes that are more costly for IDMs to develop independently, and that means the just-in-time supply chain requires even further adaptation to competing for capacity in mainstream foundries. While this presentation has been focused on current automotive supply chain disruption as the leading story in the microcontroller market right now, I would also like to leave you with a few other notable microcontroller market trends. The data processing, automotive, and edge computing markets have boasted a lot of newsworthy announcements in the increasing performance levels and demands for AI processing. However, as AI has been enabling us to scale up to tackle some very intense matrix in deep learning applications, it is also scaling down. New applications in AI targeting 2D vision, audio, and sensor hub processing is also revolutionizing advancements in the microcontroller market. Even as automakers attempt to reduce the cost, weight, and power of electronics in vehicles by reducing discrete electronic control units and moving towards centralized domains and zone control, the electrification and applications with increasing intelligence and AI continues to bolster a growing microcontroller market. With the increasing reliance on connectivity in cars, the old physical firewall of an isolated vehicle network is gone. Security in automotive and other applications is evolving the entire microcontroller market. The vertical market of secure microcontrollers is evolving into a horizontal feature of security embedded into many applications of microcontrollers. In short, I would like to leave you with the few key points of this microcontroller market forecast and come back to, I still want that car. The pandemic may change how and why we buy cars, but it has diminished effect on if and when. The early disasters and cancellations seem to be over. Still, delays are up to as much as 5 weeks for many orders. The main point I want to establish again in this presentation is that we are not really dealing with a microcontroller semiconductor market material shortage as much as we are having to readjust the supply chain just-in-time market model. It is a real possibility that in 2023 and 2024 that the adjustments will swing the other way, and we may see some overstock and price drops if you can wait that long. Thank you.
Thank you very much, Tom. Very nice presentation. Now it's time we receive many questions, so don't hesitate to keep sending the question using the Ask a Question window. Let's start with the first question. Don't automotive OEMs second source these components to prevent such catastrophic supply chain impacts?
That's a good question. The norm for the automotive industry is to have second source supply chain. But as the electronic components have advanced into more specialized features, there are some applications where a second source is not available. So as the leading independent design manufacturers do compete as second sources for many of the OEMs for classic microcontrollers, when we are talking about advanced technology nodes and advanced features within the microcontroller market, in many cases, just like system on chip solutions and graphic solutions, those choices that OEMs are being forced to make is to design around a single source. And in those cases, that may also be changing the just-in-time market model, relying on that single source. But it's a good question, and while second sourcing is still definitely a norm, it can't be implemented across the board.
Thank you, Tom. Another question. Apart from MCUs, there were other component types such as power discrete and PMICs causing some disruption as well. Could you please comment on other components types?
Yes, so this particular presentation has been focused on the microcontroller market simply because the microcontroller market, it features so prominently in the automotive industry. And this presentation the scope of this presentation has been around microcontrollers, but the question is a good one. As I tried to relate to the microcontroller market, many times the delays for the automotive industry were not necessarily for one type of component. And the microcontroller developers are oftentimes the same developers doing power ICs and PMIC devices. Those devices, those solutions are frequently bought from the same company. And what these providers have been telling me is that the just-in-time market strategic model is somewhat broken in that it is difficult to predict from one quarter or even 1 month to another which of these markets will be out of balance. 1 month it might be a PMIC, another month it might be an IGBT, and another month it might be a microcontroller, as the orders struggle to try and catch up with whichever market is out of balance. If you're familiar with the term Jacob's ladder, it's a lot like trying to climb Jacob's ladder, which is a carnival game. You apply pressure on one side and it will turn the ladder completely around. And it's impossible to understand specifically how much pressure you need to reapply without the long-term strategy of just-in-time market strategies that the market has been used to. So yes, PMICs, power semiconductors, microcontrollers, and even SoCs and graphics processors are all being affected by this imbalance.
Okay, thank you. Another question. Do you expect that the semiconductor equipment market to manufacture the semiconductors will be affected also?
Yes, the equipment manufacturers for semiconductors are part of that just-in-time strategy. The equipment manufacturers have to, or the semiconductor suppliers have to balance what they need in terms of equipment manufacturing, test, validation, assembly. All of these functions of the semiconductor manufacturing are part of that just-in-time balance procedure. And it's why it is so complex to try and rebalance. There is currently in the semiconductor supply chain difficulties in trying to estimate exactly how much of the semiconductor manufacturing equipment needs to be dedicated to which of these imbalanced semiconductor markets. Again, each of these interconnected supply chain pieces are part of the whole, and the imbalance is due to trying to shift all of these moving parts at one time. And each of them, including equipment manufacturing, semiconductor manufacturing equipment, is part of that imbalance.
Okay, let's try this question, Tom. With the advent of over-the-air software updates, do you see much longer life cycle for automobiles? And do semiconductors company needs to keep IC in production for longer periods?
That's a good question. So as I stated earlier, things like security in the automobile has had to evolve because automobiles are no longer physically isolated, and over-the-air models mean that automobiles will be part of a connected, internet-connected value chain. I don't believe that the over-the-air updates will necessarily extend the lifespan of vehicles as much as they will improve the user experience over the normal lifespan of a vehicle by updating the user experience and helping the user maintain the vehicle. I don't believe that the average consumer is more likely to own a car longer. And in fact, many other automotive impacts from different social environments, such as the electrification of vehicles and vehicles as a service that allow you to not own a vehicle, but to simply use a vehicle as a service, will have a higher impact than the ability to update those vehicles over the air. And in fact, we may see that vehicle ownership shorten due to these other impacts.
Okay, thank you. One more question. With so many billions in announced investment by foundry services over the next 2 years, is there a change that the imbalance shifts in the other direction with the good?
I alluded to that earlier, and yes, there is a definite risk involved in that with all of the semiconductor supply coming online in 2 or 3 years or 4 years down the line, that we will see a drastic oversupply and thus a drastic drop in pricing. However, most of that will actually affect higher performance processors such as SoC and graphics. I don't expect it to have as big an impact on the microcontroller market.
Thank you. Thank you very much. We still have questions, but we'll do our best to answer by email directly. The live market briefing is now ending. Thank you again, Tom, for your time and analysis. To everyone, you will soon receive an email with the link to the presentation within 24 hours. Feel free to share the presentation with colleagues. Finally, please let me remind you that you can find all our report tracks and monitors on our website, www.i-micronews.com. Do not hesitate to contact us if you have additional questions. You can find our contact details on the last slide of the presentation. Thank you all for joining us today. Have a good day and take care.